Matt Navarre with Navarre Training here to show you more integration details on using image search with AI-powered semantic search features in FileMaker Pro. Let's dive in. So in this sample database, I've got a bunch of images of some Native American art, as well as some just like random images I found off the internet. And to do a quick demonstration of how this search works, I'll search for something like red, and it finds things with red in it. Note that it's searching on the image information and not the name. I'll search for something like cat, and it shows me things that have cats. We can see these do. And if I search for feline, which is very similar, it actually shows some of the same information, but also things that it thinks are kind of feline. These similarity numbers are kind of low, so we'll take a look at more about that in a little bit. So another thing that you can do is for shades of meaning, right? I can type in happy, and it searches for images that it corresponds with the word happy. And if I search for sad, it'll search for things that it thinks are sad. Like, for example, that, not particularly super happy art. Okay. And then some other examples of more basic things, like if I search for apples, because there's some pictures of apples and some other fruit in here, it'll find that. How does this work? Let's take a look. So the database structure is this. It's a flat table that has the image as an externally stored object, and the embed, which we'll see in a second, is also a container field internally stored, which makes it much faster. So for each of the images that I have, if I look at the detail of the image, it shows me the metadata of the image itself and also the metadata of the container, that is the embed. Okay, so we see the image, and then we can see that its size is about 8K. So each embed, no matter how much it's embedding, the embed data is around 8K. This changes based on the different models that you use. In some of the other examples I looked at, it's 12K for a different, like for example, for the OpenAI model. So let's see, if we take a look at the settings, I sort of skipped past that. In order to do the embedding, it needs to get information from whatever model that you're using. In this case, the Cohere AI, I send my account name and then the API key and then which model I'm using to embed. And then for the embedding part, it's actually creating the data into the embed image. So if I go back to here, that's what goes into this field, container field. Note that you can store the embedding as text because it actually is text, but it performs much better if you store it as a container data. Let's take a look at the scripts. So we took a look at the settings in our AI configuration there. One script step that's the key here is configure AI account. So here in the Cohere model, we're sending it the Cohere account name and API key and the image model that we're using. So this step needs to run only once when you open the file to initialize it, and that works across any data in your database. Embed images, this is what actually inserts the data into the embed. So this actually does an API call using the model that you specify, which does have a cost. There is a way to do this running your own local model, which would not have a cost, but we're not showing that in this particular video. So there's some other great videos on the internet. That's not for the faint of heart, much more involved than that. Okay, then, by the way, this can actually run either as a found set, and there's another script step that embeds one object, one image. The next one, which actually shows that feature, is perform a semantic find. So this one does the search using the vector data on the image. So here's actually the text prompt image. There is actually the data that it is what's actually stored in the vector. It's just a bunch of numbers between 1 and -1 that mathematically represent the information in the image. You can either search on a found set or on all records. If you have a very large data set, you can first use regular FileMaker search to limit the found set so that it's not searching on a gigantic set of 100,000 images, because this is not fast on a very large set like that. And then you get a couple of other settings like how many images to return, if there's a minimum cosine match that you want. And then a really cool feature that's new is saved result, which actually makes a JSON object with the image information that comes back. When this command runs, it creates a found set of those records and sorts it, but it sorts it by an invisible method, which there's a way to make visible, which we'll take a look at in a second. And that's related directly to this insert embedding step that I talked about a minute ago. This runs on the one thing. So this embeds the query that you run, the prompt that you run, and then puts that into a variable so that we can then compare with the embed of each image, which gives us that cosine score. That's a lot. Okay. And then there's another script I'll show you in a minute, which is the one that does a comparison. This is even less code for how that works. Okay, so let's go back to my list and we'll kind of see this running again. So if I search for something like lion, it will bring that lion up. And then if I say, oh, I want to find other images that are similar to this, let's slow down in this case and run it actually in debugger. Run that button. So it gets the JSON, sets up the cohere account, and then runs that what am I trying to say? It runs the perform semantic query against the actual data that I'm looking at, the embedded data in this image, and finds things that it thinks are close, and then goes to the first record. So the first match in this particular case, if you're searching on an image itself, the similarity is always going to be as high as possible. I'm not sure why this one came up so high, because it doesn't look particularly similar, but maybe the file size is similar, something like that. Or most likely there's just nothing in the database that's similar to that lion. Let's take a look at some other just kind of random ones. I know that we have some other ones that are very close in here. Like here's some jewelry, right, or a necklace. Here you go. So this is kind of a little bit better. It shows you things that are more similar. If I show this one, yeah, these are very, very similar necklaces in terms of shape, color, size. And so this is a good example. This is also an amazing way to find duplicates. So if you happen to have two copies of something, let's go ahead and make one. So I'm going to take this particular one, duplicate the record so I have a duplicate. And then if I say show similar here, it's going to find the duplicate copy both with a similarity of 1. So pretty cool, because otherwise it's quite difficult to find duplicate image data. That's kind of what's going on. So with these few script steps, there's not a lot to move into your system, and you can take advantage of these great features. You'll see other videos I have that talk about this for semantic search on text, and I'm going to have lots of other AI videos coming. So keep your eyes open. Thanks for your time.